Sometimes taking a dump can be a real lifesaver. And I'm talking, of course, about heap dumps. What did you think I was talking about? I'll talk, of course, about heap dumps and using them to find and fix Node.js memory and CPU issues. Although I do have to say that I'm kind of surprised that he still has his pants on. Anyway, thank you for the introduction. I will say a few words about myself, like was said. I'm a host on the popular JavaScript Jabber podcast. It's an international podcast. It's in English. I highly recommend listening to it if you're interested in JavaScript on the front end, the back end, full stack, anywhere. I'm also an invited expert on the W3C Web Performance Working Group. And if you want to, please connect with me on X, also known as Twitter. And now let's get back to the actual story. And it's an actual horror story. Because who here has ever been a watcher or a shielder or on-call, whatever it happens to be called in your organization, and you get a call that the server is down or crashing, or maybe it's just really slow, and of course it's going to be at 2 a.m., and of course it's going to be on a Friday night or a Saturday night, so it's going to be a lot of fun to try to deal with it. And you look at the logs and you can see the crash, but otherwise everything seems to be normal. But luckily for you, you actually have monitoring for memory usage, and when you look at that, you see something that kind of looks like this. You see memory that goes up and up and up until the server crashes, and then it starts going up again, and then the server is maybe reset, and then it starts going up again until it crashes yet again. And consequently, you know, or you assume that you probably have some sort of a memory issue, potentially an actual memory leak. So that's the problem that we're going to be talking about today. And in fact, what I'm going to try to do is to provide you with the tools and techniques to become the plumber of your organization, the person that people go to whenever they encounter such a problem, because it's not a trivial problem to deal with and to fix. And that's exactly what we're going to be talking about today. But you might be asking me at this point, hey, I've heard that Node.js, or actually even JavaScript itself, is a memory collected system, garbage collected system. Aren't garbage collectors supposed to safeguard you from memory issues such as memory leaks? After all, they automate the process of managing memory. Well, as anybody who's ever lived in Israel should know, the fact that you have garbage collection does not safeguard you from garbage overflows and from leaks and stuff like that. And to understand why that is, we need to talk a little bit about how garbage collectors work, in particular in Node.js. Node.js, as I assume you all know, uses the V8 JavaScript engine, and V8 uses a garbage collection technique known as mark and sweep. It's actually a generational mark and sweep, but we won't go into that because this is not a talk about garbage collection. But a few words nonetheless. So you have a root object. The root object is the entry point of the JavaScript code into the heap. It could be the global object, it could be the current context of the function that's currently executing. And from there, we can get at a lot of objects that are located in a heap memory. Now, objects also obviously reference each other, so it becomes this kind of a graph. And in fact, it's exactly a graph. So from root, we can get to object 1 and object 3 and object 2. Object 6 and object 7 and object 8 point at each other, but they're not reachable from the root. Now, when the garbage collection kicks in, the first stage is called mark. And what happens is that it starts from the roots and then goes and scans all the objects in the heap and marks every object that it finds until it cannot mark any new objects. And of course, the objects 6, 7, and 8 have not been marked because they're not reachable from the root. They're reachable from each other, but they're not reachable from the root. So the next step is the sweep step, and in this step, the garbage collector basically collects all the objects that are unmarked and then sweeps them, which means effectively releasing their memory and freeing it up for additional use. There's also compaction and stuff like that, but again, we won't go into the details. But this should highlight the potential issue, because what it shows is the fact that the garbage collector does not release all the memory that is no longer needed. It releases the memory that can no longer be used or directly accessed, which means if there's memory that you don't need anymore, but can still be accessible, be reached and still accessible, it will not be garbage collected. And that's the root of the problem. So a common cause of a memory leak would be a global object that continues to hold on to references to objects that are supposedly no longer needed. For example, let's say you have a cache and you keep putting values in the cache in order to avoid recomputing them each and every time, but you've not put any limit, let's say, on the cache size, or the process of removing items out of the cache is slower than the rate at which objects are put into the cache, and eventually your memory will overflow. Another common cause is contexts or closures around event handlers, where you connect or listen on an event, but then never free the event handler, and it just stays there, and the closure keeps living on and holding on to references to objects that theoretically are no longer needed. So this is what the memory graph will actually look like for a node process that does not have a memory leak issue. You actually see, if you look at a high enough resolution, that the memory does constantly fluctuate, because memory is consumed, and then after a bit the garbage collection kicks in, releases the memory that is no longer usable, and then memory collects again. In fact, you can see here that Node uses a generational garbage collector, because there's a much more frequent small garbage collection that releases some but not all of the unneeded memory. And then every once in a while, a full garbage collection is executed, which releases all the memory that can be released. If you have a leak, it looks something like this. It goes up and down, but the trajectory on the whole is upward trending. And this is the problem that we are talking about today. Another important aspect is that a memory leak will not just impact your memory usage, it will also impact your CPU, and this is because of something called a GC storm. A GC storm is what happens when memory in the heap starts running low because of that leak, or because you're consuming memory at a rate that's higher than the one in which you're releasing it. And what happens is that the garbage collection is triggered more and more frequently, because the system is like really trying to free up some memory in order to be able to continue to work. And it gets to a certain point in which all the system is effectively doing is just running the garbage collection. The garbage collection is a CPU intensive process because it does need to scan a lot of memory. And if it's constantly just doing GCs, then you'll end up basically running at 100% CPU without actually doing any work. And this is actually a graph from a leak event that we had at Sisense. So we can see the memory usage. It's really fluctuating again because of the garbage collector, but overall the trajectory is upward trending. And if we look at the CPU usage at around that time, we will see that you get more and more frequent triggers of the GC going to 100% CPU each and every time. And again, in fact, taking away CPU from the process actual tasks. And the problem with memory leaks is that they are very difficult to pinpoint, because the node process has just one heap. So every part of the system is consuming memory from the same resource, from the same heap resource, which means that any part of the system, in fact, can impact all the other parts. So understanding where the problem is can be challenging, because again, everything is impacted. Another problem is that leaks often manifest only in production, because only when the system is actually under significant load. I mean, you have the leak always, but you don't notice it when the system is not loaded. Now, theoretically, we can do all sorts of load tests and load simulations, but in reality, it's very difficult to simulate actual production scenarios, and a lot of organizations just don't do it because it's so difficult to do, or if they do it, they still don't pinpoint the problem. So you have this situation where the process crashes in production, but not in your testing environment or not in your staging environment. All this makes heap problem really, really bad. They are difficult, they are catastrophic when they happen, but they are difficult to pinpoint and consequently are very difficult to fix. Luckily, we do have the tool called memory or heap dump, and it does come to the rescue in this scenario. What is a heap dump? A heap dump is a snapshot of all the reachable objects in memory at a specified point in time. In other words, all the objects that the garbage collection would not reclaim. All the ones that would be reclaimed, they're not interesting, and therefore they're excluded from the snapshot. And there are several ways in which this snapshot can be obtained, and I'm going to be talking about all of them. The first method is to use DevTools, basically connect as a debugger to the node process. Another one is using command line switches on the node process itself. And a third option is to use an API that's available within Node. And I'm going to show these things. So who wants to see actual code at this point in time? Yeah, let's go for it. It's a tech conference, so let's see some code. Okay, so I created, is it big enough? Can you actually see the font? Maybe I'll make it slightly bigger. So I created a process that's that I created intentionally in order to simulate a memory leak. So the way that I implemented it is I created a global array that I'm going to cause the leak by just putting stuff into it and never removing. Every time a request comes in, I increase the request counter, and I allocate 64K of objects that have the same structure. It's just three properties, A, B, and C, each one containing a random number. And then I basically push this object into the leaked data array, and that's about it. So every time this endpoint is hit, there's going to be a leak of 64K objects, not K RAM, K objects, not K bytes, K objects. So let's see this running. So first of all, I run it in debug mode because I'm going to show you how I use a debugger to generate the heap. And if I want to cause the dump, I can use a browser, or I can use no, why does it always want to update? And I'll just curl. And as you can see, the response in this case is just JSON that I put in place to tell me that a leak happened. And it's some additional information about the heap usage. I can do it again, and we can see that heap is going up, but it's not really very informative in terms of enabling me to pinpoint the problem. So in order to do that, I'll actually open DevTools. So what I do is I will actually go back to the browser, open a new tab, and go to Chrome Inspect. I don't have Chrome Inspect, so I'll just write it. And because I'm running with the debug command line switch on the node process, I can inspect it. And what I get is this floating DevTools, kind of similar, should be very familiar to anybody who's debugged a browser-based application, but it's not, this one is actually attached to the node process, and we can see that it doesn't have all the tabs that you're usually familiar with in the context of DevTools. For example, no elements view because there's no browser. And I'm on the memory tab. And what I will do, there are a couple of options here. I'm not going to be talking about them. They are interesting, but they are more interesting for profiling, less for finding memory leaks. I'm going to use the heap snapshot one, which is the default. And I'm basically just going to take a heap snapshot. And now I see all the objects that are in memory for this process. Now, does this actually help me? Maybe I can find out that there are a lot of instances of various things, but there's also a lot of noise here because there's a lot of stuff in memory, and it's very difficult to pinpoint and figure out what the actual leak is. So it turns out that there's a trick that we can use. What we will do is we will cause another leak, and then we will take another snapshot. And when we look at the other snapshot, instead of looking at summary, we will look at comparison. And comparison looks at the difference between the two snapshots. It looks and sees which objects were added and which objects were removed between these two snapshots. And I can immediately see that there's a lot of instances, 64K instances in fact, of an object that has the structure A, B, and C. Now, because I use the literal object, the one without a constructor, without a class, it just looks at the shape. If I'd use instances of a class, it would actually give me the constructor name. So it's fairly straightforward to identify the objects. So I can see that about 64K were allocated, 0 were deleted. Especially instances is the delta. In fact, I often just sort using the delta in order to find out what has leaked. Now, okay, so I know that these objects are leaking, but where are they leaking from? What's causing them to leak? What's preventing them from being garbage collected? So if I open this, I can see the independent instances, and if I pick one of the instances, I can see what's retaining that instance, what's holding it in memory, what's preventing it from being garbage collected. So I see that this object is being held in an array. This array is held in an object called data, which is itself in the array, the leaked data array. And that's the one that we had on the global scope. So I can understand that in this case, the problem is the leaked data array. So using the retainers going up this chain is the way to figure out and pinpoint the cause of the leak. So now we have a mechanism or a method for identifying what is leaking and also to understand what is causing the leak. And that's exactly what we want to be able to do. So we can close this and go back. So what are the benefits of this approach? First of all, it's more appropriate for the development portion. If we are able to already see that we have a leak during development, using DevTools is a great way to find and fix it. It's very easy to use. As you saw, you just launched the DevTools and it was very easy to get the heap dumps. There are a lot of tools built into DevTools. So like I said, also additional tools for profiling and stuff like that. Also, if I want to debug not just a certain point in time in the process, but the actual startup of the node process, I can put the inspect brk command line switch, which will halt the node process immediately as it's starting to load. I'll take a snapshot then. I'll take another snapshot at the end of the load process, do a comparison, and then I can debug the potential leak during the load process. But there are also several significant downsides to this approach. First of all, you need the appropriate CLI command line switches in order to enable debugging. If you don't have them, you'll need to stop the process, put in the flags, and then you've lost everything that you had in that instance. Another problem is that you need CDP access. CDP is the Chrome debugging protocol. It's that communication protocol if you launch it with the inspect flag, you see that it says, hey, I'm listening on port 9000 something, I always forget. That's the port that's used for this protocol. The problem is in a production environment, this port is probably closed, and rightly so. Now, you could use an SSH tunnel to get there, but again, this needs to be properly configured and does add another layer of complexity. Also, running with debugging switches does have a certain performance overhead. It can also accidentally cause you to break the service, because if you're running in debugger, you could just put a breakpoint in it accidentally and then just stop the service, and guess what? The whole process is frozen. So that's obviously a bad idea. And also, taking snapshots in and of itself is a very heavy process. So if your service is already loaded and already running low on resources, taking the snapshot could be the thing that pushes it over the edge. Another approach that's probably better for production environment is using node command line switches. And a very interesting one, which is actually experimental, is the heap snapshot near heap limit flag. If you put in that flag and you put in a number, and we'll explain in a minute what that number is for, when a heap limit is neared, you're kind of approaching that limit, a snapshot file will be automatically generated. You can specify also where. When you have these files, you can then load them, for example, into the Chrome DevTools. I didn't show, but you have options in the Chrome DevTools to save snapshots so that you can share them, or to load snapshots that maybe somebody else had created or that were automatically created using such a command line switch. Now, you put in a number because the node process will generate such a snapshot every time the limit is neared. And obviously, that can happen an indeterminate number of times, especially if you've got a leak. So you don't want to create like 1 million dumps, which would certainly crash your system. So you can limit how many times a dump will actually be created. You will want more than one so that you can do the comparison, but 2 or 3 or 4 is probably enough. Because again, it could be the thing that pushes you over the edge, especially if you're already nearing the heap limit. Another approach, which I think is actually potentially more useful, is to use this command line switch, the heap snapshot signal. This way, you can actually send a signal to the process and tell it that you're interested in it creating a snapshot at that time. So in this case, I told it that the signal that I'm interested in is the SIG-user2, and then I can use the kill command to send that signal to that process. I'll use a PS or something like that to actually find the process. And once that signal is received, a heap snapshot file again will be generated. And again, I can load it into DevTools and analyze it and see what the problem is. And again, I'll probably want to create more than one so that I can do a comparison. And I don't want to wait too long between them because again, otherwise the comparison will be too noisy as well. So what are the benefits and limitations of this approach? The main benefit is that it's a set and forget. You can just put it in your production environment and it has no implications, no overhead as long as it's not used. And if you actually need it, then send the signal and you'll get the heap dump. Again, no overhead when it's unused. And it's secure because you're not opening any special ports in order for this to be used. And the signal can only be sent from that same computer. The downside is that it does require some sort of SSH access. First of all, so that you can log in order to send a signal, if that's the mechanism that you're using, and also in order to be able to download that file that got generated, unless you somehow configure it to be placed into some sort of a shared resource. If you are writing it on the server itself, these files can be very big, so make sure to remove them, because otherwise you'll eventually just run out of disk space. And like I mentioned before, taking the snapshot itself can be very heavy. And in fact, if the process is already very constrained, it and of itself can cause the server to crash or be terminated, let's say, using the OM killer. Another approach, which I mentioned, is to use an API. Node itself, you don't need to import anything. You don't need to install anything special, nothing from NPM. Node itself has built-in functionality that it gets from V8. So this is an example of how this API looks like. I just imported the write heap snapshot function from Node itself. So this approach has also upsides and downsides. You have total control over if and when that API is invoked. And again, there's no overhead if you don't actually invoke it. On the downside, you do need to take into account certain security considerations. For example, I said that one way is to attach it to an HTTP port, but then theoretically, anybody with access to that port could generate a heap dump. And as we said, heap dumps, creating them is intensive, so somebody could DDoS your service with heap dumps. Again, disk space on the server, and again, the heap dump itself is a heavy process and can actually cause the process itself to go down. Another thing that's really important to mention is that the heap dumps probably will contain sensitive information because they contain information about the entire contents of the memory of the heap of that node service. All the things that are already decrypted because they're in use will be in that heap dump. So you need to think about regulations that you need to adhere to, like PII or HIPAA, and really taking that into account and think about how those heap dumps are stored, where they're stored, how they're transferred, and make sure that they're removed. There's no sanitation on this information. So to summarize what we've learned today, first of all, GC does not prevent memory leaks. It's very useful, it's very helpful, we all enjoy using it, we all love having it, but we can still get into a situation where memory usage is not good. Leaks are challenging to find and fix because they can be anywhere in the application and they impact the application as a whole. Using heap dumps is a great way to find and identify where the problems are so that you can fix them. There are multiple methods to obtain them. We saw you can use DevTools, you can use the command line switches, you can use APIs. You use the comparisons to find the deltas so that you can identify what is actually leaking versus just objects that reside in memory. And then you can use that retainers list to identify what is actually holding on to that object and preventing it from being released. Once you do make a fix, it's really important to verify the fix because we've all been in situations where we fix one problem only to uncover yet another problem in the code. So rinse and repeat and make sure that you've actually fixed the problem. And be careful about security because, as I said, heap dumps, for example, might contain really sensitive information. And with that, go out and be the plumbers of your organization. Thank you very much.